Our world is a symphony of sound. The rumble of distant thunder, the rhythm of rain on a rooftop, the murmur of 1,000 conversations blending into one. Our planet hums, it sings, it roars with the energy of life. But travel just a few hundred kilometers up, beyond the thin, protective veil of our atmosphere, and an incredible transformation occurs. Everything falls silent. The silence of space is not just an absence of noise, it's a fundamental state of being. It's a quiet so profound, so absolute, it can feel both peaceful and terrifying. We look out at the swirling galaxies, the brilliant burning stars, and we imagine a cosmic orchestra. But in reality, the universe's grandest events, supernovas exploding with the force of billions of suns, galaxies colliding in a slow, majestic dance, unfold in utter silence. Why? Why is the cosmos so full of unimaginable power and drama, so breathtakingly quiet? The answer lies in the very nature of sound itself. Sound, as we experience it, is a mechanical wave. Imagine striking a bell. The metal vibrates, pushing against the air molecules around it. Those molecules push against their neighbors, which push against theirs, creating a chain reaction, a wave of compression and rarefaction that travels through the air to our eardrums. Sound needs a medium. It needs particles, atoms, and molecules to carry its energy from one point to another. Whether it's air, water, or solid ground, sound is a physical disturbance traveling through matter. But space is, for all intents and purposes, a vacuum, an almost perfect vacuum. In the vast stretches between stars and galaxies, the density of matter is astonishingly low. You might find only a few hydrogen atoms per cubic meter. That's trillions upon trillions of times less dense than the air we breathe. With so few particles, so far apart, there is simply nothing to carry the vibrations. A sound wave trying to travel through deep space is like a shout with no air to carry it. The vibrations die instantly, unable to propagate. The universe isn't quiet because it's hiding its sounds. It's quiet because the stage for sound to perform on doesn't exist. It is nature's ultimate soundproof chamber. And yet, to say the universe is completely mute isn't the whole story. While the vacuum of interstellar space is too sparse for sound, there are pockets where matter is dense enough to carry vibrations. Within the colossal clouds of gas and dust known as nebulae, where stars are born, sound waves can exist. Scientists have detected pressure waves rippling through the Perseus galaxy cluster, generated by the immense energy output of a supermassive black hole at its center. These are not sounds our ears could ever perceive. They are incredibly deep, low-frequency notes, a B-flat 57 octaves below middle C. The wavelength is so immense that one single oscillation takes over 10 million years to complete. It's a cosmic hum, a whisper so slow and deep that it's woven into the very fabric of the galaxy itself. These are the true phantom sounds of the cosmos, a bass line resonating across millennia. So, if our ears are useless in the vacuum, how do we listen to the universe? We have developed other senses, other ways of tuning into the cosmic broadcast. Our radio telescopes are like giant, sensitive ears, capturing the faint radio waves that have traveled for billions of years from distant galaxies, pulsars, and the afterglow of the Big Bang itself. These signals, when converted into sound, reveal a universe that is anything but silent. It crackles with the rhythmic ticking of pulsars, the static hiss of ancient radiation, and the whistles and chirps of planetary magnetospheres. We can hear the energetic bursts of X-rays from black holes devouring stars, and we can translate the light from distant suns into a spectrum of frequencies, each element singing its own unique song. Most profoundly, we have learned to detect gravitational waves, ripples in the fabric of space-time itself. First predicted by Einstein a century ago, these waves are not sound, but something far more fundamental. They are distortions of reality, created by the most cataclysmic events in the cosmos, like the collision of two black holes. When our detectors, like LIGO and Virgo, register a gravitational wave, they convert its signal into a sound we can hear. A faint, rising chirp that lasts for less than a second. In that fleeting moment, we are hearing the echo of a collision that warped space-time itself. a silent song that traveled across 1 billion light-years to reach us. These are the hidden rhythms of the universe, a beat to which galaxies dance, a sound woven not from matter, but from the geometry of existence. And so we return to our small blue world, floating in this vast, silent ocean. From the quiet emptiness of space, Earth appears as a beacon of vibrant energy. The sounds of our planet, the crash of waves, the rustle of leaves, the chorus of life, are impossibly rare and precious. They are a testament to the unique conditions that allow for an atmosphere, for water, for life itself. The profound silence of the cosmos doesn't make our world feel small or insignificant. Instead, it frames it. It highlights just how extraordinary sound, and the life that creates it, truly is. Perhaps the silence of deep space isn't an emptiness to be feared, but a canvas. It's a backdrop of profound stillness against which the music of life can be heard. In all this quiet, our noisy, chaotic, beautiful world is the universe's most intricate and precious song. The cosmos is silent, not because it has nothing to say, but because it is waiting, patiently, for us to develop new ways to listen. And in that silence, as we tune our instruments to the whispers of radio waves and the rhythm of space-time, we begin to understand our own place in the soundless symphony of existence. The universe may be silent, so that we can finally learn to listen. Thank you for joining us on this journey into the quiet of the cosmos. If you found this exploration as awe-inspiring as we did, consider subscribing and following for more deep dives into the mysteries of our universe.